All right, guys. So let's look at this first one here. So picking up where we stopped on Tuesday, we have this problem here. Now, the first step in solving these is really to cancel out all the denominators. Because if we can eliminate all the denominators, it's going to make these a lot easier to work. And looking at the three denominators, well, we have x minus 2 and x plus 2. Both of these here are as simplified as it gets. We can't factor, we can't do anything to them, so we can leave them alone. But the x squared minus 4 is factorable. And it would factor to what? X minus 2 and x plus 2. Because that is a difference of perfect squares. So what do we need to multiply each one of these by to get the denominators to cancel? Yes, x minus 2 and x plus 2, or we can say x plus 2 and x minus 2. Now in our first rational expression, the x minus 2 and x minus 2 would cancel. In the middle one, the x plus 2 and x plus 2 would cancel. In the last one, we would have the x minus 2 and x minus 2, and the x plus 2 and x plus 2 cancel, which is going to leave us with 9 times x plus 2 plus 6x times x minus 2, which is equal to 9x squared. Now, before we get too far, we do need to state the restrictions. Because it's going to be good to know what x cannot be, so that when we find out the values of x, if one of them is the restrictions, we know it will not work. So what are our two restrictions here? So it'd be figuring out what makes x plus 2 and x minus 2 0. No, you're good. So 2 and negative 2, because 2 minus 2 would give us 0, and negative 2 plus 2 would also give us 0. So it's figuring out what's going to make those 0. And really what we're doing is setting both of those equal to 0 and solving for the value of x. Any questions on this so far about the restrictions or how we got to this part here? Now we just need to solve for the value of x. Well, here we can distribute the 9, and 9 times x is going to be 9x, plus 9 times 2 is going to give us 18, plus, now we can multiply through by the 6x. 6x times x is going to give us 6x squared. And 6x times negative 2 is going to be negative 12x is equal to 9x squared. Now at this point here we can combine like terms, and most likely we're going to need to get this equal to 0 because we do have an x squared term. You're welcome. Now if we combine like terms on the left hand side, we'll have 6x squared. Apparently I'm going to scroll down. So we'd have the 6x squared. Now the 9x and negative 12x are like terms, and we can combine those. Well, 9x minus 12x would be negative plus 18 is equal to 9x squared. Now we do need to get this equal to 0. So we would subtract the 9x squared from both sides. And if we subtract 9x squared from both sides, well, 6x squared minus 9x squared is negative 3x squared. Minus 3x plus 18 is equal to 0. Because 9x squared minus 9x squared would cancel out, leaving us with 0. Now I have a feeling at this point here y'all want to solve this by factoring, because that seems a little bit easier. Now when we factor this here, we do need to see, is there a greatest common factor between our negative 3x squared, our negative 3x, and 18? Negative 3. Now I'm going to take out the negative 3, mainly because I do want the x squared to be positive. Because if we can keep the variable with the biggest exponent positive, especially in these quadratics, it makes factoring go a little bit easier. So if we factor a negative 3 out of negative 3x squared, we're left with x squared. And if we factor a negative 3 out of negative 3x, we have plus x minus 6 is equal to 0. So the negative really just changed all the signs from negative to positive or positive to negative. Factoring out the 3 gave us our x squared, x, and negative 6. So here we're going to have negative 3 and 2 sets of parentheses is equal to 0, because this here will factor. Now since the 6 is negative, our signs are going to be positive and negative. And the factors of x squared are x and x. And what factors of 6 do we want for this here? 2 and 3, and which one's positive, which one's negative? 3 would be positive and the 2 would be negative. And if we did check this here, it would come out to be a positive x. And last but not least, we do need to finish solving this here. Because I do have two things multiplied together to equal 0, so one of them must be 0. So either x plus 3 is equal to 0, or x minus 2 is equal to 0. Now with the x plus 3, to solve for the value of x, we would subtract 3 from both sides, telling us x is equal to negative 3. For x minus 2, we would add 2 to both sides, telling us x is equal to 2. So once we got finished solving this here, we found that the solutions for this here is at negative 3 and 2. But what were our restrictions? X cannot be what? 2 or negative 2. Well, one of our restrictions did show up, so that one does not work, which tells us that x is equal to negative 3 is the one solution. So there's only one solution for this one here. Any questions on any of this here? Are you ready for the next one? Now we can go on and factor this before we find our restrictions. Now looking at this problem here, x minus 1 does not simplify. There's no way to factor to make it easier to work with. It's just going to be x minus 1. But the x squared minus 1 is factorable, and it would be x plus 1 and x minus 1. So we did go on and multiply on the last one, but let's go on and find the restrictions first for this here. So what values of x would make the denominator 0? 1 and negative 1. Because 1 would make the x minus 1 and x minus 1 0. The negative 1 would make the x plus 1 0. So whatever our solutions are, we cannot have 1 or negative 1, because if we have either one of those values, it will not work. Now, knowing that, we can move on and actually solving. So what would we need to multiply each of these terms by? X plus 1 and x minus 1. And in our first rational expression, the x minus 1 and x minus 1 would cancel out. Now, in the middle, the 5, does it have a denominator? No, so nothing will simplify with the 5. But with the 6, the x plus 1 and x minus 1 would cancel with the x plus 1 and x minus 1. So it would simplify out. Leaving us with, on the first one, we have 7 times x plus 1 minus 5 times, which would be x squared minus 1, is equal to 6. Because it's perfectly fine to have it as x plus 1 times x minus 1. Because if we multiply it back together, we do get x squared minus 1. Bless you. And the reason we can just say x squared minus 1 as well, we got the x plus 1 times x minus 1 from our x squared minus 1. Those are the factors of it, so we can just put them back together. Now we do need to simplify, do some simplification. So here we can distribute the 7. 7 times x is 7x. 7 times 1 is going to be plus 7. Now we need to distribute the negative 5. Negative 5 times x squared is going to be negative 5x squared. Negative 5 times negative 1 is going to be plus 5 is equal to 6. Now we do need to combine like terms, and most likely we're going to have to get everything on one side and have it equal to 0. Well, on the left-hand side, we do have the negative 5x squared. There's no other x squared term, so it is going to be by itself. Plus 7x, because there's no other terms with x. Plus is equal to 6. So we do need this equal to what? So what would we need to do to get this equal to 0? We need to minus 6 from both sides. And if we subtract 6 from both sides, we get negative x squared plus 7x plus 6 is equal to 0. Any questions on how we got to this quadratic? Now at this point here, it looks like we can factor, and we can. Is there a greatest common factor we can pull out between these three terms? No. There's not a number that is divisible by both 5, 7, and 6, or a factor of 5, 7, and 6 that we can pull out. But there is something that I do want to pull out of this. The negative. And there's nothing wrong with that. It's just I like having the x squared term be positive, because it's a little bit easier to work with, at least for me, when trying to factor and find the factors. Because if we pull that negative out, we can see what the signs are going to be a little bit easier. Because here, since the 6 is negative, 1 is going to be positive, 1 is going to be negative. Now we need to find the factors of 5x squared. Well, we do know that we'll have x and x, and the factors of 5 are 5 and 1. Where do we want to put the 5? It's the positive or the negative? We'll put it with the positive. Now we need to find the factors of 6, so 1 and 6, or 2 and 3. Try 2 and 3 first. Where do we want to put the 2? 2 and 3. And last but not least, we can check this. Well, 5 times negative 3 is 15x. 2 times 3 is going to be plus 2x, which gives us a negative 13x. So that's not quite what we wanted, but that's fine. Because we can switch the 2 and 3 and have 3 and 2. And if we check it again, 5x times negative 2 is going to be negative 10x. 3 times x is plus 3x, which would give us a negative Is that what we wanted? Yes. So these here would be the correct factors. And we have that 5x plus 3 is equal to 0, and x minus 2 is equal to 0. Now for our 5x plus 3 is equal to 0, well, the first thing we can do is subtract 3 from both sides, which will tell us that 5x is equal to. And last but not least, we would divide by 5, telling us x is equal to negative 3 fifths. Well, for the x minus 2, we would add 2 to both sides, telling us x is equal to 2. Any other questions on this here? Are you good with this here? If there are no other questions on this here, we'll go on and look at the last one. So this is the last problem that we're going to look at with 7.52. Now looking at this one here, we do need to simplify the denominators and find out what the restrictions are. Now, x minus 1 and x plus 1, those won't simplify. They're already as simplified as it gets. Now the x squared minus x minus 2 will factor. Because the 2 is negative, our signs are going to be opposite. One's going to be positive, one's going to be negative. The factors of x squared are going to be x and x. And the factors of 2 are, well, 1 and 2. 2, is it going to be positive or negative? Negative, and the 1 is going to be positive. Now that does help us find out what the restrictions are, because x cannot be what? Negative 1 or positive 2. Because we can't have positive or negative 1 because the x plus 1 and x minus 1. And we can't have positive 2 because of the x minus 2. So here we actually have 3 restrictions, unlike the others where we've had 1 or 2. So if we have any of these 3 values as the solution, or comes up as the solution, it will not work. Okay? Now what do we need to multiply each one of these by? Well, so we know we'll need an x plus 1, x minus 1, and x minus 2. We have x plus 1, x minus 1, and x minus 2. So x plus 1, x minus 1, and x minus 2. And then we do this multiplication. In the first one, the x minus 1 and x minus 1 would cancel. In the middle, the x plus 1 and x plus 1 would cancel. In the last one, the x plus 1 and x plus 1 would cancel. The x minus 2 and x minus 2 would cancel out, leaving us with 2 times what? Yes. X squared minus x minus 2, because the x squared minus x minus 2 factor down to x plus 1 times x minus 2, which is exactly what we're multiplying in the first one, so we can put it back. Plus, in the middle we have 1 times x minus 1 times x minus 2. Well, did we factor that from anything? Well, no. So we will have to do that multiplication out. Is equal to, well, 1 times x minus 1. Well, luckily enough, on the right-hand side, that's as simplified as it gets. On the left-hand side, we're going to have to do some distributing. So the first thing we can do is actually multiply through with the 2. So 2 times x squared is squared. 2 times negative x would be negative 2x. And 2 times negative 2 is negative 4. Plus, here we're going to need to distribute. So x times x would give us x squared. X times negative 2 would be our negative 2x. And then we'll do the same thing with negative 1. Negative 1 times x is negative x. And negative 1 times 2 is going to be plus 2 is equal to x minus 1. Now at this point here, we can go on and combine like terms. Well, our x squared and 2x squared will add together to be 3x squared. Our negative 2x, and negative x give us negative 5x. And lastly, the negative 4 plus 2 is negative 2. Now we still have a quadratic term, our x squared, so we need this equal to 0. So the first thing we can do is, doesn't really matter, we can not subtract 1, but add 1. And then we would need to subtract the x. Now if you wanted to do this in one step, you could, because you could subtract x and add 1 all at the same time. That's perfectly fine. I'm going to go on and do it in 2 steps. And if we do those there, we get 3x squared minus 6x minus 1 is equal to 0. Any questions on this so far? Yes. Here? I have a feeling some of y'all have started factoring this, yes? How did that go? No. Not good. Because here we're trying to find factors of 3 and 1 that would multiply and then add together to give us 6. Well, that's not going to happen. Because really we would need the negative 1 to be something bigger, or really the 1 to be something bigger. So we're looking for 2, 3, then we have a better chance of it working. So here we can't factor it, but we can still use the quadratic formula. Because factoring does work as long as we have whole number or rational solutions. If it's not a whole number or rational solution, factoring doesn't work. So we have to go back to the quadratic formula. And as a reminder, we're looking back at this as ax squared plus bx plus c. So in this case here, we would have negative b, which would be our negative 6, which is just really going to become positive 6, because the negative and negative make a positive. Plus or minus the square root of negative 6 squared minus 4 times a, which is positive 3, times c is negative 1, over 2a, which would be our 2 times 3. Now here I am rewriting it all out, because if we wanted to, we could simplify some of these steps. because our negative 6 is really just positive 6. The denominator 2 times positive 3 is going to be a positive 6. Now for the radical, if we're plugging this into a graphing calculator, I would put everything inside the radical first. So I wouldn't use the square root, but I would take 6 squared minus 4 times 3 times negative 1. And I believe that should give us a positive 48. Because our 36, or 6 squared, negative 6 squared is going to be 36. Minus 4 times 3 is 12, times negative 1 would give us a negative 12, which would actually give us 36 plus 12, which would give us 48. Any questions on this so far? Now we do need to take the square root of 48 or simplify it. And most likely this is not going to turn out to be a whole number if we tried in the graphing calculator. But 48 is 16 times 3. And if we take the square root of 16, that gives us 4, and we have the square root of 3. Now, this isn't technically the most simplest form because there is a greatest common factor between all 3 of these numbers, which is 2. Now, if we wanted to, we could actually skip over to the answer, because if I simplify these all by 2, on top, the 6 and 4 would become 3 plus or minus 2 square root of 3, and the denominator would become 3, and that there would be the answer. Now the real way we're getting to that is we factor a 2 out of the numerator, which leaves us with 3 plus or minus 2 square root of 3 all over 6. 2 divided by 6 reduces to 1/3, and we're left with our answer here. Now is this going to be a whole number? No, because of the square root of 3, it's an irrational number. Now, what did we say the restrictions were? Negative 1, 2, and 1, yes? Is 3 plus or minus 2 square root of 3 over 3 one of those? No. So, that is actually the answer. And part of the reason I showed you this one and wanted us to look through this is to show you that the answers for these don't have to be whole numbers or nice fractions. They can be these irrational numbers. And if we actually worked out one and got I, it means that there's no real solution for this. That the place where these intersect is actually in the complex realm. So there wouldn't be an actual solution. Questions on any of these here? And that is the last part of the lesson notes for chapter 7.52. So your homework is on page 400, problems 23 through 26, 29, and